All right, so now we're going to talk about schedules of reinforcement. So we've already gone over the basics of operant conditioning. We talked about our antecedent, our behavior, our consequence. And the next module, we're going to talk mostly about our antecedents, or what we call about stimulus control. We already talked about sort of the initial components of operant conditioning with our behavior, but this section is going to focus on our consequence, or how do we arrange schedules of our consequence and what impacts does that have on the actual behavior and operant behavior that we are interested in. So from this section, I'm hoping that we will be able to define 4 different schedules of reinforcement and explain how each schedule influences steady state behavior. So we'll talk about 4 different ones. I want you to be able to name those 4 and then describe the impacts they have on steady state behavior. I want you to compare continuous and intermittent schedules of reinforcement in terms of behavioral strength or overall momentum and resistance to extinction. And then I want you to argue and justify your approach to using continuous or intermittent schedules of reinforcement in your training and handling. So here are going to be questions in which I want you to take the information I'm going to give you, think about it, think about what it is that you do, and then argue and justify what you think might be the best approach, which you'll then be submitting as part of this course. Okay, so what are our schedules of reinforcement? So reinforcement schedules describe how consequences are arranged. So we're totally in that C side of the 3-term contingency, or that consequence side. So how are these different kinds of consequences are arranged? And what must occur for reinforcement to be presented? What does the animal have to do? And do they have to engage in one response, multiple responses, a very fast burst of responses, a short burst of responses? What is required to receive that reinforcer? That is our schedule of reinforcement. So first, we can break sort of our types of schedules of reinforcement into 2 broad categories. First are going to be our continuous schedules of reinforcement, and then are going to be our intermittent schedules of reinforcement. I like to use the example of a Coke machine as a planned sort of continuous schedule of reinforcement, meaning that every response that you make, every time you put your money in and push a button, it is anticipated that you would receive your reinforcer, in this case, a Coke. Whereas on intermittent schedules of reinforcement, there should be a strong learning history that every time you push a button or put your money in, push the button, the reinforcement is not anticipated every single response, that there's going to be some schedule or some type of relationship between the number of responses and the number of reinforcers, but it's going to be intermittent, meaning that not every response is going to produce a reinforcer. So we can break these schedules up into 4 major different types. They're going to be the fixed ratio, variable ratio, fixed interval, variable interval. We're going to break down each one of these, and then these are the ones that I anticipate for you to be able to describe, as well as be able to indicate how behavior changes on each of these different kinds of schedules. So first, let's separate the ratio versus the interval component. So a ratio are going to be when reinforcers occur after a certain number of responses, whereas intervals are going to be reinforcers that occur after the first response after a certain period. So intervals are going to be time-based. Ratios are going to be the number of responses that are required. So an interval would be if there was some type of timer that after a certain particular period of time, then the first response would get reinforced. Ratio is going to be the number of individual responses that must be made before a reinforcer is delivered. So fixed are going to be when the requirements for a reinforcer do not change from one reinforcer to the next. It means that you define, say, your schedule to be fixed for some, say, value of 2, which means that every time there's going to be exactly 2 behavioral units required, or if it's a fixed ratio 2, that you would need exactly 2 responses every single time. Whereas variable means that the requirement from one reinforcer to the next can change after every reinforcer delivery, meaning that it's not predictable exactly how many responses are required before the reinforcer is delivered. This would be a variable schedule of reinforcement. So now we can take those two words, or two categories of words, fixed versus variable, ratio versus interval, and produce those four schedules. So a variable ratio would mean that the reinforcer is delivered after an average of n responses. So it means that if we had a variable ratio of 3, then the reinforcer is delivered after an average of 3 responses. Not always 3 responses. Sometimes it could be 1, sometimes it could be 6, sometimes it could be 2, sometimes it could be 5. So it's variable after around some mean number of responses. A fixed ratio could be very similar, but we don't have that variability built into it. It is fixed. So it would be after exactly 3 responses. Every time you make 3 responses, that is when the reinforcer is delivered. And then variable interval is going to be that time base. So the reinforcer is delivered after the first response, after an average of t minutes. So if we had a value of 3 here, that would mean that the first response that occurs on average after 3 minutes is reinforced. Sometimes that timer might be set to 1 minute. Sometimes that timer might be set to 6 minutes. But on average, it would average out to about 3 minutes. Whereas the fixed interval would have exactly 3 minutes. There would be no averaging component to it. The reinforcer would be delivered after the first response after 3 minutes. So it would be very strongly time-based. So an FR30, and this is typically how we write it. We would write the FR followed by the number, or the FI followed by the seconds, or the VR followed by the number of responses, or VI followed by the number of seconds. So if we had a value of 30, and FR30 would mean that every 30th response is reinforced. So you would deliver a reinforcer after response number 30, after response number 60, after response number 90, etc. FI 30 seconds would mean that after 30 seconds, the first response that occurs is going to be reinforced, but that timer will always be set to 30 seconds. Variable ratio 30 means that reinforcement after on average 30 responses. Sometimes it might be 5, sometimes it might be 60. There will be some average around that value of 30, but it's not always going to be 30. It will be variable around that value of 30. And then a variable interval 30 seconds is going to be reinforcement after 30 seconds on average. So that timer that was with the FI of exactly 30 seconds will vary to sometimes between 5 seconds to sometimes between 60 seconds. But it'll be the first response after that timer times out that will be reinforced. So to sort of break this down a little bit into our continuous and our intermittent schedules of reinforcement, our continuous schedules are going to be basically our fixed ratio 1. That is our only example of a continuous schedule of reinforcement. So our Coke machine, our continuous schedule of reinforcement, is an FR1. That means that every response that is made is reinforced. And so that is continuous. But then once we get into the intermittent land, I guess, if you will, of schedules of reinforcement, we can then break them down into, are they ratio or interval? And are they fixed or are they variable? And then we can have some, in a minute, I guess continuous would be a fixed ratio 1, but anything other than fixed ratio 1, fixed ratio 2, 3, 4, variable ratio 2, 3, 4, fixed interval of all of these fixed interval or variable interval would all be examples of intermittent schedules of reinforcement, where not every single response is reinforced, that some responses are reinforced, other responses are not reinforced. So, what types of behavioral patterns do these tend to produce? Well, for the most part, these schedules of reinforcement, interestingly enough, tend to produce very ordinal or very steady and stable patterns of behavior across a wide variety of species in what we call sort of steady state behavior, meaning that there's a difference here, and an important difference, that there's a difference between learning a new behavior and then having that behavior move to one of these schedules of reinforcement, and then what that level of behavior is under one of these schedules of reinforcement. So I'm not necessarily talking here about early training or early imprinting. In most of those situations, you pretty much always use a continuous schedule of reinforcement and are looking at an FR1. This will be more of after the animal has acquired that particular behavior. So say, for example, you use an FR1 to train a sit when you say sit, and you've built that very strongly. You may then transfer it to an intermittent schedule of reinforcement so that you're not reinforcing that every single time. Then after you transition it to that intermittent schedule of reinforcement for a certain period of time, this is the steady state behavior, or that level of behavior that we're going to be talking about here, is what is that long-term rates of behavior after they've already learned what that sort of intermittent schedule of reinforcement is going to be. So we're going to talk briefly about cumulative records and how we study these, largely because this is how we're going to discuss and describe the different types of steady state behaviors under these schedules of reinforcement. So the cumulative record is basically an old-fashioned way of how behavior was recorded in these cases. So an animal might be making a simple response, like a pigeon pecking a key or a rodent pressing a lever, where essentially each response is sort of made by a little switch, and every time that that switch closes, this little pen can move up along this line, and you have a continuous paper scrolling. So it's kind of like if you can think of it, that you might have seen before, like a seismograph or something, where you have this kind of continuous record, or maybe like an EKG, where you have this continuous record in time, where this paper is scrolling at a specific period of time. And every time a response occurs, it kind of ticks up on this paper. These are nice because they provide real-time and continuous recording of behavior, but then it also makes it very easy to see patterns of behavior. So as you can think of time, the paper is scrolling and moving slowly. These are very few responses over a period of time, or this would be a very slow rate of behavior. Whereas in this case, this would be a very fast rate of behavior because the pen is ticking up very, very quickly as time is sort of moving on. Okay, so fixed ratio schedules, let's talk about those first. So a fixed ratio schedule, say for example, a dog would get a treat after every third sit. So this would be an example of an FR3 situation. What type of behavioral patterns do we see under that? So for the most part, under these types of behavioral contingencies, we see relatively strong rates of behavior. So the animal will make lots and lots of responses because their responses are contingent on how many their payoff or schedule, or the number of reinforcers that they get is directly related to the number of responses that they make. So you typically get relatively high rates of responses. So you get response, 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 reinforcer, response, 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 reinforcer, etc. A couple of things that we do see on these schedules is that as we go from lower to higher levels of fixed ratios, and again, this is mostly from rodent stuff. For dogs, these numbers might look quite different. But for the most part, at low levels of fixed ratio schedules, you see relatively continuous high rates of responses. As you sort of build up higher and higher fixed ratios of schedules, you get a slightly different pattern and behavior. And this is what we call sort of a pause and run pattern of behavior. And what you'll see is that there'll be lots of responses that are made. The animal will get the reinforcer, and then there'll be this long pause before they start again. So you can kind of imagine and think about it this even within your own behavior, is that sometimes when there is a very heavy load to do, you're going to have to engage in a lot of response or a lot of work before you get that reinforcer. You might find that every time you get that you'll work really, 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 really fast, get that reinforcer. After you get that reinforcer, it's like, now it's time to relax, and it's going to take me a little while before I then start my next burst of work to get to that next reinforcer. So it produces this kind of pause, run, pause, run, pause, run kind of pattern of performance that particularly occurs at higher rates of ratio schedules. The level of this pausing tends to be directly proportional to this rate of this ratio, so that the higher this level of responses that are required, the longer the pause, the longer that you wait or almost procrastinate, if you will, before you engage in that run kind of response. So we see this pause, run, reinforcer, followed by pause, run, reinforcer, pause, run, reinforcer. And the pause increases with ratio size, and we call this a sort of post-reinforcement pause. This is, you've got the reinforcer, I now pause before I then build that next burst of responses. So one thing that you can see is that if you're running some type of fixed ratio schedule of reinforcement, that there might be longer and longer pauses. When that occurs, that indicates that your ratio is probably too high for what it is that you are looking for. So also within the ratio schedule family, right, are going to be our variable ratio schedules. This could be quite similar to our fixed ratio of 3 or a fixed ratio of whatever the number happens to be. But instead of it always being the exact number of responses, it's going to be a variable number of responses, sometimes 2, sometimes 1, sometimes 10, sometimes 12. And this produces a different pattern of responses. So remember before we would see this pause, run, pause, run, pause, run kind of pattern. But if you don't know when your next reinforcer is going to be delivered, maybe it'll only just be one response before the next reinforcer is delivered. Maybe it'll only take 2 responses. Maybe it'll take 65 responses or 100 responses. But because of that variability built in, it tends to generate a relatively high and constant response rates. And in these cases, we tend to see little to no pausing. Right after you have that reinforcer delivered, you pick back up and immediately go on to the next schedule, because that next reinforcer could actually be very, very few responses away. So part of the power of that variable reinforcer schedule is that you can see here that you have this, period of lots of responses, and then finally a reinforcer, lots of responses, a reinforcer, lots of responses, a reinforcer, just a couple of responses, reinforcer, lots of responses, reinforcer, little responses, reinforcer, little responses, reinforcer, that you never know when that reinforcer is coming, and it might only take just a couple more presses or a couple more responses until that reinforcer is delivered. So this tends to generate that variability and unknown component, very strong levels of responses at really high rates that are pretty continuous without those kinds of pausing. Our fixed interval schedules are going to be time-based. So this is going to be after a certain period of time, our timer will turn out, and then the reinforcer will be delivered after that first response following the timer. This tends to generate what we call a scallop pattern of behavior, because the animals do have internal clocks, and they can time quite well when a timer is about to time out, or when it is about time for my treat. So this could be an example that may not be purposeful in detection training, is that, remember we talked about the odor, or coming across the odor in of itself could be a reinforcer. If, perhaps we set our hide such that on average, or that typically it takes exactly 5 minutes to come across to the hide, we might incidentally be building a fixed interval kind of schedule of reinforcement, where the search behavior really is only going to be reinforced for finding the target odor after exactly 2 minutes of 2 minutes of time, where they could basically be just walking and not searching for anything for a period of time. Then it's getting to approximately 2 minutes. So now then they have to engage in their search response, and then they will find something, because their hide is always approximately 2 minutes into the search. But nonetheless, on a fixed interval schedule of, say, this one looks about 6 minutes, every 6 minutes, a schedule turns out. You have a period where there's no responses, because this is too close to your interval, so it's unlikely that any responses will get paid. But then as it gets longer and longer within the session, you get higher rates of responses. The reinforcer is delivered, and then that follows a period of very few responses, because the timer is not for a period of time. So then they wait out the timer, and then as they get closer and closer, there'll be an increase in response rate, followed by a drop off, followed by an increase, followed by a drop off, followed by an increase. Similar to our fixed ratio, those pauses increase with interval duration. So the longer your duration, the longer there's going to be those pause periods. We can also have our variable interval schedule of reinforcement. So just like our fixed interval of schedule of reinforcement, there's still a timer. And then once that first response occurs after that timer is timed out, that will get sort of reinforced. And in this case, because of the variability built in, we don't see that that pausing that occurs after a reinforcer that's delivered, because that interval could time out at any time. So that removes that pausing, and we tend to get relatively steady states of behavior across that. So like the variable ratio, there are no pausing, and it's a relatively steady sort of pattern of responding, but it tends to be much lower than our ratio patterns of responding, because in our ratios, the number of reinforcers you get is directly proportional to the amount of work that you put in, right? The number of times that you respond is going to predict exactly the number of reinforcers that you get. On the other hand, with a interval kind of schedule, the number of responses you produce, if you produce tons of responses, that doesn't really change anything because it's time-based, or there's got to be a certain period of time. It would be like checking your email. If you check your email and click the refresh button, you could do that 10,000 times. That's not going to change the number of emails that you get, right? Those emails are going to be coming based off of some type of more broad time schedule or something like that. I guess it is related to the number of emails you send out, but nonetheless, clicking the refresh button on your email server for when an email comes in, that's not going to speed necessarily anything up. It's going to be a certain period of time it's going to take for that email to come in. And clicking that refresh button, it does not going to matter whether you click it 1 or 100 times. It doesn't really change that in any way. So the type of typical patterns of responses that we see is that on our variable ratio of schedules of reinforcement, we get really high and fast rates that are relatively stable. On our fixed ratio, variable ratio, on our fixed ratio, we have these pause run patterns, and this length of pausing is related to the sort of magnitude of your ratio schedule. So whether you have a high ratio or a short ratio, the larger your ratio, the longer this pausing. The variable interval will be relatively stable, but will be at a much lower rate. And our fixed interval is going to have this kind of scallopy pattern that will sort of include these pauses that occur right after reinforcer is delivered. So if you want really high rates of behavior that are relatively stable, the fixed ratio types of schedule of reinforcement is going to be the obvious answer. If you want something that is easier to manage, like a fixed ratio, you will potentially have consequences of these sort of pause and run patterns. And with your variable interval, you get a sort of a nice pattern of responses, but are not going to be as fast or as high as what you might get from some type of variable ratio schedule. In terms of terminology, we can call the schedules rich versus lean, where rich are going to be high rates of reinforcement. So like our continuous schedule, or an FR1, that would be a very rich schedule, or an FR2 or a VR2, right? Things that require very few responses and you get lots of reinforcement. Whereas you can have lean or low rates of reinforcement, might be a schedule where in FR 500, where it's going to take 500 responses until you get a reinforcer, you're going to get much less reinforcement on that schedule than an FR2, where it takes only 2 responses to get a reinforcer. Or a fixed interval 10 minutes versus a fixed interval 1 minute. The fixed interval 10 minutes is going to be a lean schedule of reinforcement, low levels of reinforcement, whereas our fixed interval 1 minute is going to be a rich or a high rate of reinforcement on that schedule. So FR 1000 would be rich, an FR1 would be rich, lots of reinforcement delivered. FR 1000 would be lean, it takes lots of responses to then get a reinforcer. A ratio schedule can be too lean, right, and cause what we call ratio strain. So if you set a ratio schedule of 1000 would be a good example, but sometimes even with dogs, a ratio of 30. So say, for example, you are running a detection dog scenario where you're only going to deliver your terminal final reinforcer after 30 correct, trained final alerts occur correctly to the target odor. That would be a relatively lean schedule. And you can have situations where you build the schedule to be so lean that pausing that occurs might become so long that the behavior fundamentally extinguishes, or we get extinction, and that all responses decline. And that's where we sort of call as ratio strain. Where that ratio strain occurs can be very individualistic, right? The amount of work the animal is willing to put in under extinction conditions or without getting the reinforcer can differ from one animal to another. But if you're paying attention to what is your schedule of reinforcement, then particularly what is your schedule of reinforcement of the ratio of how much search behavior is required to finding a target odor is a good example. You can get to a situation where that ratio becomes too lean and you start to see degradation of behavior or extinction of search behavior because your ratio or the amount of payoff to the amount of work that's put in might become too lean. And that can be a very individualistic measure as well from one animal to the next. There are other kinds of schedules of reinforcement that are relatively simple. They're what we call a differential reinforcement of a high rate. So this is where you must respond more than n responses to get a reinforcer for a period of time, meaning that you just got to respond a lot really, really fast. And you can do the opposite. You can have differential reinforcement of low rates, where over a period of time, you just can't respond more than n number of times. And then another is what we call non-contingent reinforcement. And this is where it does not relate to the number of responses that are required. So you can make 0 responses, 2 responses, 3 responses. It doesn't really matter at all. They are time-based. So we have what's called fixed time. So it'd basically be like setting your stopwatch for 2 minutes. And after 2 minutes occurs, the buzzer goes off and you deliver the reinforcer. Or you could have variable time where on average it's 2 minutes, sometimes it's 1 minute, sometimes it's 3 minutes. Here you don't have any response requirement. It's non-contingent to any type of response. Sometimes we call it non-contingent reward, but basically what it means is that it is completely schedule-based, and whether the animal is engaging in a response or not, it doesn't really matter. You just deliver it based off of some type of time schedule. So with that, we will then move on into extinction.